All right, today's review video, we're going to be doing one of these every day, and we were going to review an FRQ today, and we're still going to be doing that, but there's still several people who have not got the political FRQ done that I added. You had until Wednesday of this week to do that, but you were supposed to have FRQ progress check number 4 done last week. And we're going to wait one more day, and then we're going to go over that one right here in the review section tomorrow. We may also go over some other things you're seeing on FRQs. Like one thing we're going to be talking about today in the agricultural video of the notes is something some of you are running into on FRQs, which when it mentions land use and land utilization. And what does that mean? And it's actually a simpler term than probably you're thinking. It really just has to do to how do we use our land based on the situations that we're given. So what I thought I would do today is show you a way that we can review, because we know units 1 through 5 are going to be on our test, show you a way we can review in the modern day and when things are crazy around us as they kind of are right now, or I guess big time are right now. Let me show you some things that you're seeing every day that we can put geography into context and into work. Of course, we're all seeing more than we want to see. News coverage probably about the coronavirus and all these maps. The one you see on the screen right now probably is one similar to you that you saw. And we could span this thing, we could go across and we could look at Europe, and this is showing the number of cases around the world. We could change it to deaths. But what I want to show you on this is how geography has played a role. I heard an interview the other day where they were talking about why this has gotten so bad and why it's historical. And the word globalization was mentioned, and that we live in a world today that's more connected than ever before because of things like technology, time-space compression. The ability for people to get from one place of the world to another is so much easier now, so that when a virus breaks out that's highly contagious, it's not a matter of if, it's only a matter of when. And if you'll remember, we talked about that with epidemiology. So this case of the coronavirus and its pandemic, which means at a grand, large world scale, highly contagious, and also globally, it's been infected, or people around the world have been infected by it, as opposed to an epidemic, which is a large scale, but it's more regionalized. But so many words and terms that we've used. Epidemiology. A lot of you have asked, is this a stage 5 type scenario? Not really the stage 5 of epidemiology that was hypothetically predicted where something returns, but there are some elements of the coronavirus that fit some people's fear of a stage 5. It's something that our bodies are not immune to. It's something our bodies have never had to fight before. So therefore, it's a brand new game, and we're having, our bodies are and will adapt most likely over time, but we're getting hit with something we've not seen. There's no vaccine for it as of yet. There's no great treatment as of yet for this virus. So those are things that relate to more of a stage 5 scenario in epidemiology. If you don't remember your epidemiological stages, please go back and review those, stages 1 through 4 especially. But stage 5 was always hypothetical. So maybe this is that potential stage 5, because as you may be hearing, there is potential for this virus to come back in the fall. There's potential for this virus to come back yearly. Seasons may not be affecting it very much. There's a lot of geography involved in understanding what's going on with this. So revisit Omron's epidemiological transition of what typically kills people in different stages. And then with that, let me throw some terms at you here. And I'm going to leave it. I'm not going to explain my way through all these because I want you to practice it. Practice using terms like distance decay, globalization, time-space convergence, and the gravity model to explain the coronavirus epidemic. If you'll remember, the gravity model is about how connected places are. Well, the more connected places are, the more likely disease is to spread. And if you'll remember, the gravity model suggests that distance matters, but population size matters more. And so they both matter. So if we look at these maps and we're trying to see how geography relates, do you see a type of diffusion on this map? Because I do. More than one. How is coronavirus being transmitted? How is it diffusing from China originally to other parts of the world, including the United States? Here in East Tennessee, we've not been hit by a lot of cases yet. Yet is the key word. Knox County now has over 40 cases. So what's happening? Well, look at America's cases. Big city, big city, big city, big city. The gravity model. Big city to big city have more interactions. We call this hierarchical diffusion. It's working its way down. Look at the Midwest, where you have very few large cities. Look at how they've basically been spared so far. Hierarchical diffusion tells us these places will get the disease will come in, or the sickness will come in a little bit later. They'll be the last ones to deal with it. Here, we're not dealing with it a whole lot yet, but it seems to be coming. Hierarchical diffusion is taking place, but it's not the only kind. So is contagious diffusion. Diseases like the coronavirus are typically, one of the reasons they're so bad is there is so many combinations of how they diffuse, hierarchically and contagiously. If we're following hierarchical diffusion for us in this part of the country, we need to watch Knoxville. Because whatever happens in Knoxville, which it gets to basically hierarchically from other people in connection to businesses and stuff in Knoxville, then it's going to start spreading contagiously to places around Knoxville, which include this area. Now, obviously, relocation diffusion can also cause coronavirus to spread, but notice how key terminology of stuff we've talked about help explain the world situations. I mean, I can bring this thing out and we can look at the world. It's a little hard to look at from this, but look at South America, where it's just kind of starting. If we keep zooming in there, you're going to very much see a hierarchical approach to the diffusion. Something else. Notice this right down here in the bottom. Okay? I'm going to bring it up on the full screen. This is the global cases. You've probably heard the scientists talking about flattening the curve. Well, we don't have to learn about the curve for this class as far as epidemiology goes, but guys, think about what this looks like. Exponential growth is a J curve, which should remind you of Thomas Malthus, and also might remind you of population checks, as bad as that sounds. But you've got this J showing. They want to flatten the curve. That's what social distancing and all this stuff is about, so that the hospitals don't deal with a big spike in cases. If you listen closely, the doctors will even talk about, well, in Italy today, the number of people infected, new infections, is lower than it was yesterday. In other words, the number of cases has still grown in Italy, but they're not growing by as much. Remember population. In this part, the growth is exponentially increasing. But when the slope of the curve begins to flatten out a little bit, you're still seeing growth and you're still having problems, but the number of new cases and deaths today may be or would be less than the ones from yesterday. So this is a great way to go back and review your population, demographic transition stage 1, 2, 3, 4, how to graph all those things, and what does exponential growth mean? Because remember, in population, Malthus's fear, too many people we can't take care of, we can't feed if we keep growing at this rate. That's the same thing the doctors are worried about in New York and other parts of the world, that they're going to run out of those supplies. They may not need them all yet, but they're not going to be able to treat all those people. Where if we can flatten that curve out, then that'll give them a better chance to deal with this issue. Something else related to all of this that we are seeing around the world is you've probably heard of how bad this has been in places like Italy or Spain, and it has. We look over here at number of cases. The U.S., of course, bigger population, is at the top, but Italy is at 97,000 cases. Spain at 85,000. Italy has the highest number of deaths over here, almost 11,000. Spain, 7,000. Remember what we talked about with elderly dependency, stage 4 and 5 countries. China's an early 4. And we don't know how reliable their numbers are. But Spain and Italy, one reason they've been hit so hard is the susceptibility of people with preconditions health-wise in the elderly clientele. Italy and Spain had lots of those people. America does too. Not quite as many as Italy and Spain, but it makes you worry about a place like Florida and what could potentially happen there. So elderly dependency ratio, review your ratios. If you have an elderly dependency like 0.4, that's close to Italy's, I think, 0.4 something, that's 0.4 elderly to the independent population. For every one independent, there's 0.4 of an elderly dependent over the age of 65. Guys, we're bombarded with this stuff right now. Let's try to take what's going on and let's try to use it for some stuff that can help us as we try to prepare for this content and this test. Hope this has helped some. If you got questions, let me know. Another video coming up over today's new notes in just a few minutes.